Hello second years, so we're going to start a new topic today and we'll do our best with this, and you can let me know in comments in Google Classroom or through email if there's something that's not working for you. So we're going to start with the topic of coordinate geometry. Now you'll have actually done some of this before in first year, but just in case you don't remember, we're going to go over some of the basic concepts again from the beginning. So we're going to start by talking about the Cartesian plane. Okay, and it's called the Cartesian plane. It's named after a mathematician called René Descartes, who was a famous philosopher as well. He's famous for the phrase, "I think, therefore I am." And I recommend you look him up because he's quite interesting. He's also been involved in calculus and a number of other very interesting areas of maths, if you find those things interesting. So we're going to start by coordinating the plane. So this is the first thing that we're going to look at today. Coordinating the plane is the header. And at any point when you want to pause to take notes or ask me a question, just pause the video and you can do that. So coordinating the plane. First of all, what's a plane? Well, when you were doing geometry in first year, you learned about things like points and lines and rays, and all of those things can be represented on a flat piece of paper. Any flat two-dimensional surface is referred to as a plane. So a plane is a two-dimensional surface, a 2D surface. And the Cartesian plane, or the coordinate plane that we use, is always represented by two axes, and the two axes are just number lines. So if we imagine that we draw our usual number line, and of course we know that numbers go on forever in both directions. Our positive numbers go one direction and our negative numbers go the other direction. So imagine our number line, 0 in the middle, and each of the whole numbers going up on each box like this. We'll just go as far as 5 in each direction. Then the negative numbers are below 0 and they go in the opposite direction. And again, we'll just go as far as 5 with those as well. This is our standard number line, and going horizontally across like this, we call it the x-axis. Okay? To make two dimensions, all we do is we draw a second number line going through the 0 point. So our second number line is going to be at a 90-degree angle. We sometimes use the word orthogonal to our first number line, like this. And going up instead of going right is where we fill in our positive numbers, 1, 2, 3, 4, 5. And going down is where we fill in our negative numbers, -1, -2, -3, -4, -5. So if you haven't already done so, pause the video to draw your x and your y axis. So the y axis is always going up and your x axis is always going across. Now, what do we do with this? Well, we can use it to refer to any locations in two-dimensional space. So if I put some points, and the points, for whole number points, they're always going to be at an intersection of boxes. They'll never be in the middle. So you'll notice on your number lines, the numbers are right on the lines. You don't put the number in the middle of the boxes. That's one of the main mistakes that people make. And so our points will be right on the intersection of two lines like that, where they cross over. I'm going to call this the point A. We do a second one up here, we'll call it B. Maybe have one over here, C. What happens if one of them is on the line, like this? D, or on one of the other lines, E, F, G. Now again, you might pause the video to copy the points that I've put down there. And what we're going to do is we're going to write down the coordinates. Write down the coordinates of the points A, B, C, D, E, F, and G. All points are always written using two numbers inside of round brackets. And the way we remember the values that we fill in is that X will always come before Y. I'm just going to move the camera down a little bit here. Hopefully you can see this okay. X always comes before Y. What's a good way of remembering that? Well, X comes before Y in the alphabet. So that's one easy way of remembering it. The other thing, the other way that I like to remember it, is that when you learn to walk and jump, you always walk first and then jump. So when I want to fill in the coordinates of the point A, I look, how far over did I walk? I walked 2 spaces over and then I jumped 1 space up. So the point A, I walked 2 spaces over and I jumped 1 space up. Point B, I walked 3 spaces over and I jumped 4 spaces up. 3 spaces over, 4 spaces up. C, I walked backwards 2 spaces and then I jumped up 2 spaces. D is on an axis. What happened? I didn't walk over at all. I stayed where I was. I jumped down 4 spaces straight away without walking at all. So that 0 shows that I didn't walk side to side at all. I just jumped straight down. You might pause the video and think about what you'd fill in for E, F, and G. For E, I walked backwards 4 spaces and I jumped up 1. F. Now you'll notice sometimes I put a circle around the point. You don't have to do that. It just makes it stand out a little bit more in your diagram. So for F, I walked over 4 spaces and I jumped down 4 spaces. -4, -4. And for G, where is G? Oh, it's over here. I walked over 5 spaces, but I didn't jump up or down at all. So I have my 0 there. Okay, so the point there is that you walk before you jump. Now, it's easy enough to read the points. What about if we were asked to plot some points? So plot the following. And we're going to plot the points H. We'll make them both positive. 2, 4. I. -1, -3. J. Let's have one that starts at 0. 0, 3. K. Let's put the 0 on the other side. -3, 0. L. minus 2 minus 5 m minus 1, 5. Excuse me. So when we're plotting these, we remember we walk before we jump. So the x value always comes first. Plotting h, I walk over 2 spaces and I jump up 4 spaces. So let me just move this. Hopefully you can see this okay. I walk over 2 spaces and I jump up 4 spaces, and that's the point H. You can write the letter anywhere nearby it. I go backwards 1 space and I go down 3 spaces. J, I don't walk. I don't go left or right. I just jump up 3 spaces, 0, 3. So I jump up 3 spaces. When it's on the axis, I almost always put a circle around it. K, minus 3, 0. So I go backwards 3 and then I don't jump up or down at all. It's K. L, minus 2, minus 5. Walk back 2, jump down 5. It's L. M, minus 1, plus 5. Walk backwards 1, jump up 5. And that's the point M. So I'm going to give you some of these to do for homework as well. I'll put this up at the end as well, and I'll put a screenshot of it in Google Classroom. So you're going to be asked to name some points and then plot some points. You'll copy these into your homework copy. But moving on to something that you should have done in first year, but maybe you don't fully remember, I'm going to quickly move on to the distance formula. So the distance formula is one of many formulas that we use that helps us find the length of a line between any 2 points. If I look again at the diagram that we just drew, if I want to find the distance between the points A and B, for example, I can draw a line and I can measure it, but my boxes aren't in. I can certainly measure it with a ruler and find out how many centimetres are between it. Looks like about 4.5 centimetres. But that's not really useful because my boxes aren't in centimetres. So when we're finding the distance between points, what we're finding is if each of these represents a unit, if each of the spaces between the numbers represents a unit, then how many units are there between different points? And as you can see, sure, I can count 1 box over and 3 boxes up, but that's not the shortest distance between the lines, between the points. So how do I find the distance between the points? Well, we have a formula for it. The formula is in our log tables as well. But I really, really recommend that we learn this off. And it looks a little bit complicated the first time you see it. We say that the distance between 2 points A and B, and hopefully you recognize this notation from when you were in first year, the distance between 2 points is given by the square root, our square root sign, of x2 minus x1 all squared plus y2 minus y1 all squared. Okay, that looks a little bit intimidating. What's this x1, x2, y1, y2 business? Well, it comes from this idea where my points A and B are defined as my first point has an x and a y value, and my second point has an x and a y value. And because this is my first point, x1, y1, and this is my second point, so x2, y2. And that's the formula. Okay, well, how do we use that? Like I said, that's in our log tables, but please do consider learning it off. It's really, really useful in coordinate geometry. Just like in area and volume, the formulas are in the log tables, but it's much easier if we actually learn them off and write them down every time we use them. Turn this a little bit. So for my first example, we're going to say, find the distance between the points A, and I'm going to use the A that we had here, A, which is 2, 1, and B, which is 3, 4. Okay, so the first thing we'll do is we'll write down our formula. Look, I know it's there already, doesn't matter. The more times we write it down, the easier it's going to be to remember it. So the distance from A to B is the square root of x2 minus x1 all squared plus y2 minus y1 all squared. And what are x2 and x1? Well, I said my first point is x1, y1. I usually just write it above it like that. And my second point is x2, y2. And I write it above it like that. Okay, so how do I use that? Well, we've learned how to do substitution. Substitution means that we replace each of our values with brackets and we fill in the values then. So that means that the distance from A to B is going to be the square root of x2, 3, minus x1, 2, all squared, plus y2, 4, minus y1, 1, all squared. You can type that into your calculator in one go and get the answer if you want to. I'm going to do it in a couple of steps just to show you how it works out, but you will get full marks if you type that into your calculator as it is. So that's going to give me the square root of 3 take 2 is 1, 1 squared, plus 4 take 1 is 3, 3 squared. And that's going to be the square root of 1 plus 9, which is the square root of 10. Now, if you type the square root of 10 into your calculator, it will just leave it like that. And it is fine to leave your answer with a square root in it if the calculator doesn't simplify it. You know, if I type in the square root of 16, for example, into my calculator, it's going to change it to 4. So we wouldn't leave an answer as the square root of 16, we'd always change it to 4, but it's fine to leave it with a square root in the answer unless the question asks for 2 decimal places or something like that. Fine to leave the square root sign in your answer. Okay. Hopefully some of you remember doing that in first year, but if you don't, you might take some time to go over that and make sure you understand it. And if you're finding it hard, let me know. I'm going to do a second example with some minus signs in it. And this time we're going to give our answer to 2 decimal places. So find the distance between the points. We'll use A again, 2, 1, and B, not B, sorry. C, minus 2, 0. Okay, again, I'm going to write down my formula every time that I use it. It's going to help me remember it. The distance from A to B, the distance from A to C, in this case, is the square root of x2 minus x1 all squared plus y2 minus y1 all squared. I label my points x1, y1 and x2, y2, and then I fill into the formula. You know, it doesn't matter which one you decide is the first point and which one you decide is the second point, because the distance between A and C is always going to be the same as the distance between C and A. Distance doesn't care about what direction you go in. Right, so filling into my formula, I get the square root of x2, so it's always the second one first, minus 2 all squared, plus y2, 0 minus 1 all squared. And you can put that straight into your calculator, just be careful with the signs, and get the answer out straight away. I'll do it in steps though. That's the square root of minus 2 take 2 is minus 4. And when you square a negative number, you're going to get a positive number. So that will be the square root of 4 squared, minus 4 squared and 4 squared, it's the same thing, 16 plus 1. Oh, I forgot to say, we're going to give your answer to 2 decimal places. And I'm after smudging this, so I'll write it again down here. So that's the square root of 16 plus 1, which is the square root of 17. Now, again, when I type into my calculator, hope you can see this, the square root of 17, it just gives me the square root of 17, then I press my SD button, and that is approximately 4.12. What units? These aren't centimetres, they're not meters, they're not kilometres, they're just units. So in coordinate geometry, you can, if you want to talk about distance and area, talk about units and square units, but it's fine to leave them out as well because they're not specified. Okay, so that is coordinating the plane and distance formula. And for homework, you're going to do, hold this out here. The plotting and naming of points that we showed, that I'm going to show again at the end of this video, but I'm also going to upload a screenshot of it. And I also want you to do page 277, question 1. So you're going to practice using the distance formula there as well. And you can let me know if you run into any trouble. Tomorrow at the start of the video, I will go through the corrections of that homework. Okay, I hope you're able to understand everything. Just let me know if you have any questions. Yes, and I said I'd show this again at the end of the video. So here we go. This is the homework. There'll be a screenshot up in Google Classroom. Okay, goodbye. Talk to you tomorrow.